Right now, you are hurtling through space at over 600,000 miles per hour, and you don't even feel it. The universe is expanding faster than light itself, and there's an invisible wall around us that we can never cross. This isn't science fiction. This is the edge of everything we can ever observe. And today we're going to race toward it. Imagine standing on Earth and looking up at the night sky. Every star you see is just a tiny fraction of what's actually out there. The observable universe stretches 46 billion light years in every direction. But here's the mind-bending part. There's more beyond that edge, way more. Let's start our journey. We leave Earth behind, and within seconds, the moon becomes a pale dot. Mars shrinks to nothing. Jupiter, with all its massive storms, looks like a tiny marble. Neptune disappears completely, and suddenly, we're in the vast darkness between stars. The nearest star system, Alpha Centauri, is over 4 light years away. That means if you traveled at the speed of light, which is the fastest anything can go in our universe, it would still take you 4 years to get there. But we're going to cheat physics today and go much faster.
As we zoom outward, the Milky Way galaxy comes into view. Our entire solar system is just one insignificant speck in a spiral arm of this cosmic pinwheel. The Milky Way contains between 100 billion and 400 billion stars, each one potentially hosting planets. Some of those planets might have life. But we keep going, past the Magellanic Clouds, which are dwarf galaxies orbiting our own, past Andromeda, our nearest major galactic neighbor, hurtling toward us for a collision in about 4 billion years. Don't worry though, we'll be long gone by then. Now we're entering the cosmic web. Galaxies aren't scattered randomly through space. They form massive filaments and walls separated by enormous voids of nearly empty space, the largest structures in the universe. These filaments contain thousands of galaxies, all held together by invisible threads of dark matter. Speaking of dark matter, everything you've ever seen, touched, or experienced makes up less than 5% of the universe. Dark matter accounts for about 27%, and we have no idea what it is. We know it's there because we can see its gravitational effects, but it doesn't interact with light at all. We push deeper into space, billions of light years from home. The galaxies around us start looking younger. Here's why. When you look at a galaxy 1 billion light years away, you're seeing it as it was 1 billion years ago, because that's how long its light took to reach you. We're not just traveling through space, we're traveling backward through time. The further we go, the younger the universe becomes. Galaxies look more chaotic, more violent. They're colliding and merging more frequently. Stars are being born at incredible rate in massive stellar nurseries.
Now we're 13 billion light years from Earth. The universe here is less than 1 billion years old. The first galaxies are just forming from primordial hydrogen and helium. These ancient galaxies are smaller and stranger than the ones we know. This is cosmic dawn, the moment when the first stars ignited and began burning away the fog of neutral hydrogen that filled the early universe. Before this period, the universe was literally dark. No stars, no galaxies, just a hot, dense soup of elementary particles. We're approaching the edge now, 13.8 billion light years out. The light we see here began its journey just after the Big Bang itself. But wait, the universe is only 13.8 billion years old, so shouldn't the edge be 13.8 billion light years away? Here's the catch. The universe has been expanding this entire time. While that ancient light was traveling toward us, space itself was stretching. So the objects that emitted that light are now 46 billion light years away. That's the edge of the observable universe. What are we seeing at this boundary? Not galaxies, not stars. We've gone back too far for those. What we see is the cosmic microwave background radiation. It's the leftover heat from the Big Bang itself, a faint glow that fills all of space. When we look at this ancient light, we're seeing the universe when it was just 380,000 years old, a baby compared to its current age. Before this moment, the universe was so hot and dense that light couldn't travel freely. It was trapped, bouncing between particles in an opaque fog.
So what lies beyond this cosmic horizon? The honest answer is, we don't know, and we can never know. The expansion of space means that light from beyond the observable universe hasn't had time to reach us yet. It never will. The universe is expanding faster than light can travel through it in certain regions. There could be infinite galaxies out there, infinite worlds, infinite possibilities, but they exist beyond our cosmic event horizon, forever invisible to us. Some scientists theorize that our observable universe might be just one bubble in an infinite multiverse. Each bubble universe could have different physical laws, different constants of nature. In some of these other universes, stars might never form. In others, electrons might be heavier than protons, completely changing chemistry as we know it. Some universes might have extra dimensions of space beyond our familiar three. Others might have different speeds of light or even different types of fundamental forces. The multiverse hypothesis suggests that every possible universe exists somewhere. It's both humbling and terrifying. But here's what we do know. Our observable universe is vast, almost incomprehensibly so. And yet it represents just a tiny fraction of what might exist beyond our horizon. We've traveled from Earth to the edge of observable reality, from the familiar to the utterly alien, from the present day back to the birth of time itself. And we've discovered that the universe is far stranger and more wonderful than we ever imagined. Every answer raises new questions. Every discovery opens new mysteries. That invisible wall around us, the cosmic horizon, isn't a barrier to human curiosity. It's an invitation, a reminder that there's always more to explore, more to understand, more to wonder about. You're standing on a tiny planet, orbiting an average star in an ordinary galaxy, in a universe so vast that our entire observable bubble might be just one among infinite others. And somehow, against all odds, you exist to contemplate it all. That might be the most extraordinary thing of all. So the next time you look up at the night sky, remember, you're not just looking at stars. You're looking at the edge of infinity. And somewhere beyond what we can ever see, the universe continues its mysterious dance, forever beyond our reach, yet forever fueling our imagination.